Hi guys, welcome to today's stream, Plumbers of Data Science podcast. Today we are going to look into data frames. We have the last stream was full of RDDs and map and reduce and everything, and working with Spark, and that was great. That was a lot of fun for me. The source code, by the way, is down in the description. And if you go to, let me just show it to you. Where is the cookbook? If you go to the cookbook, then there is now a new folder, code examples. Code, you can't hear me, right? Yeah, you can hear me. Okay. Yeah. Code examples, and there I put the examples from day 3 with the movies txt. Yeah, so today we're going to do a lot of data framing. Yeah, okay. Hi guys, hi Nick, Dimitri, Sebastian, Rodney. Hi. How's it going, guys? Hope you had a great day. I'm coming from a birthday party home, so let me just as a entrance, let me just bring quickly up my LinkedIn. Why we're going to look at data frames today. So where was that? Yeah, here. Next is 2 interviews. What do you mean? You had 2 interviews, or? Hi, Dragonfly. So why we're going to check out data frames today is in the last stream we did RDDs and so on, and Jacek Laskowski, we looked at his awesome Spark documentation. I think it was in part 2 of the data of the Spark week, and he commented on the post, why not focus on data frame instead and simply mention RDD? I consider RDD API a Spark assembler, and I think most people don't really need to know much about RDDs. So he's also talking a lot, or he implies here that the RDD API is yesterday's news, and I mentioned this because I'm coming from the MapReduce side, and for me, RDDs, I've done some work with RDDs, and I really liked it because I was used to mapping and reducing and so on and so on. But let's look into today. I want to take some time and look into the data frame stuff. What we have learned already, and what I think is one of the big points. Let me just go over here. So what I have learned in the last stream, and what I think is one of the big points working with data frames, is that it makes it easier for beginners, because you don't need to go so low level with RDDs, and it's super easy if you have SQL knowledge, because you basically work with it like SQL tables. And as an example, we can go here and, for instance, look at this RDD. Where was that? I mean, the data frame. We had the data frame here where we did date and genre. And so we did a new data frame, date and genre, and we RDD, we create a data frame, and then we register this as a temporary table. This means from now on you can do it, you can access it with SQL. And then where was that here down below? Date and genre. Date and genre. Date and genre. Okay, we already counted here. Let me just select star from date and genre. This should work. No. What? Oh no, I hope I didn't move it. Let me just check something. I need to hide my screen. Because I think when I added this to the file to the cookbook, I didn't copy it, I moved it. And that was stupid. Yeah, I totally did that. Okay, now it should work again. Just don't want to show you my my Explorer. Okay, run everything again, and now it should work. So the idea is when you're creating a RDD, I'm always confusing RDD and data frame. So when you create a data frame is more like, or is like a table. And so when you look at it, let me just scroll down what we have created now. So it's basically in a table view, you have a column header, a column name, and then these are defined previously, or when you create the data frame, and then you have the columns in this thing. And this makes it possible to access it in a SQL manner, because basically if you think about SQL, what are you doing? You're selecting and doing stuff with tables. It basically that's basically what you're doing all the time. Of course, you're doing some joins and so on. You can also do this here. But this is basically the cool thing and the easy thing. And this is also something people ask me, what should we do in the beginning? What should we learn to get into Spark and so on? And I think this is the answer here. If you want to go in at Spark, and nowadays you are working with data frames, you're going to need SQL statements, because you are going to interact with data frames through SQL queries. So it's a good idea to learn SQL, learn how to work with SQL. So this is one thing to keep in mind. So actually now what I have been looking at before we started the stream was what is the data frame hiding for in Spark? What is it hiding? Where is it used? And let me just quickly, if I can. No, you cannot run away from Spark, from SQL. I mean, it's the logical choice, and it's a good choice, because a lot of people know SQL, and SQL makes totally sense, and so it's what people know, and it's what people are going to use. And I didn't understand this previously, but with the example from last time, this makes it very, very clear. And yeah, SQL should be mandatory for all data engineers. I mean, at least some SQL knowledge. I have this. Do I have this here at work? I have this at work. Yeah, I have a SQL book that is 2004. Yeah, I had this I got this in 2004, and it's still viable. It's still working. The basics are still all there. So you need SQL. At least you need a lot, as much SQL knowledge that if you're unsure, you know what to Google. As always. Yeah. So what is the data frame actually hiding? And I was curious a bit about what the data frame is actually hiding, and why would you use that? Because RDDs seem low level, and low level usually is from an execution standpoint. Why isn't my tablet not working? Very very good in performance, but yeah. Come on, I forgot to switch it on. Okay. The idea here, as I understand it, and what I have found today, is this plan optimization. And why isn't it writing? Come on. Okay, let's ignore it for now. So the idea here is you have your data frame, and when you want to do distributed processing, you need somehow to make this whole execution logical, and you need to distribute the information over the workers and so on. So how all this works, because basically in the end, you're working with RDDs, or the Spark is working with RDDs, as I understand it. So you're ending up with you have a data frame, and you're making SQL queries, and then it creates basically a plan what to do with this, and then it optimizes this plan, and then through a cost model it selects a plan, and then it creates the code to process the RDDs and to work with the RDDs. And this in a simple, I'll just check something. So this is how I understand it, and here are a few examples. Okay, now it works. Stupid thing. A few examples. Let me just go. So here's basically when you have, in this example, you have two data frames, this users and this events, and you want to join them and then filter. And the problem is this join. This is expensive to do, because you're working with two full data frames. And what the system is doing behind is it figures out basically how to optimize this plan, so that you have your events, and then you filter before that, and then you can make the join better with those two, and it makes more sense, and it's getting quicker. And this is basically some optimization. Here's a better example. Just yeah, it's basically the same. You have the logical plan. This is what you're coding. You have your two data frames, you join them, you filter them, and then Spark is in the background, is working with this and is creating this. And then you have some intelligent data sources. I'm not sure what this means, but yeah, it's somehow the scan here is already filtered. Not sure about this, but this is, as I see it, this is the basic thing. What do they have a bit more here? No. So in the end, this thing is going to work with RDDs, and the data frame API the how you work with the data frames, this then is going to get optimized on execution, so that it's you have more performance. And this is, I think, why data frames sometimes or are faster than RDDs. It's this optimization here. This because you think that RDDs should be quicker and should make, because it's more low level, but this optimization stuff, this is basically this here, this stuff. This is where the performance is. And yeah, so this is very interesting to learn, very interesting to find out. Yeah. And so now comes the question about what I had in mind about today's stream. So basically, we wanted to do some Kafka stuff and so on. So I moved this into what are data frames, why data frame, how do they work, reading data frames, and so on. So I think what we resolved, why, because it's easy to work with SQL and easy accessible, and it's getting optimized. And how do they work? We already checked this out. So these three, I think we already have some kind of down. So they are, we can check, and check. Now it's getting interesting. Okay, before we go do that, if you like this stream, please support what you like. I have down in the links, I have a link to my Patreon where you can become a patron and send over some support each month. I also have links for all the podcast equipment I'm using, and these are Amazon links. So if you use one of these links and buy either one of these items, one of that I'm using here for all the podcast, or something else, doesn't matter, I get a small commission, and this helps me make this stream self-sufficient, because I've been paying here, and at some point I want to get more help to get you more content and bring you better content. So for everyone who already is a patron, thanks a lot, and who is supporting this stream, thanks a lot. Yeah, so reading data frames, what we have seen in the last episode is reading what we have tried here. Let me just go up. Yeah, for instance, we read a Parquet file directly into a data frame. This basically works good. We also this was a way to get CSV files, and they are ending up directly into data frames. So basically, the data frame integration is already very good. It makes a lot of sense, and I like it. So I don't know if you guys have already worked a lot with data frames. What I'm curious about is the modification of data frames. So with RDDs, you have the whole, you're doing loops and you're working with partitions. And here, as I see it, mostly, or you can do a lot of stuff just with SQL. And how does that exactly work? And how does that work with Kafka, with message queues? So this would be two things to find out. Is one thing I already had prepared, I think. Where was that? here in this example, you created a data set. No, create data set, create data frame. Yeah, so basically what you can do is you can make spark.sql, so you can make SQL queries on top of a data frame, and then, yeah. Or is this it? So, in this case, so I'm not 100% with data frames. I'm not the Plus data set is the third. Yeah, data set is the new one. This is beyond me right now. So I actually have no idea what they are doing here. What I can see is what we can do, or we can try here, is we have read this. What was this input as data frame? What did that look? How did that look? What was in there? I guess I didn't real input df. It did. Input df. Okay, this was everything here. So my guess is that what we could do is we can make a new select. So we could. The one thing I don't really like here is you don't have selected calls df equals input as df dot. I don't know if there is a. Okay. No, there were. Do I use SQL here already, or do I use Spark dot? How did they do this here? They used. Where was that? Spark.sql. And Spark, what was Spark here? How did that work? SQL can run by starting the SQL. How is that? Why is that not working from people? Okay. 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 So I'm guessing so this is live coding. I'm totally new to the data frame stuff. I know our data scientists are working a lot with data frames and Python, but for me, until now, data frames. Spark.sql. Select. How was that? Let me just quickly check. Okay, I need. Select. What do we want to select? We want to select year, and title. Select year, title. Do I need to add a comma? Oh man. From input df. Okay. Let's just register selected calls. Let's see if this works. So it looks good. And then let's just go down here and make a new line. SQL selected calls. Yeah, okay, that's yeah. Nick asks, so why do you work with RDDs mostly? The thing is, when you're, as I have seen it, when you, for instance, get messages and you're working a lot with time series data and so on, and most of the stuff you do, for instance, you want to take data from Kafka, make simple transformations, put it back into Kafka, or you want to get data from Kafka and you want to store it on HDFS and store it somewhere else. A super simple way is just take it out from Kafka as RDDs, and then just make a quick map where you then basically reformat your line and then send it back up somewhere else. And this is with RDDs. I always found it very, very simple to do, especially if you're having messy data. This data that we're using here, the columns are all working nicely, so there is not no line where a column is missing and so on. And with RDDs, you can then use the try method, and you can then after that filter out only working, only map results who worked and so on. So and you can also find out what didn't work. And so RDDs are very low level, but mostly for transformations and so on, I always liked it. So that data I got from that's also in the, let me just I have that in the pull request. Can't you read this here from here? Spark code day 3. Here's the link. Sebastian posted this link on LinkedIn, and I used one of these. Yes, would you tell how to work with time series data with Kafka Spark 2? It's always a bit dangerous. We can find a very simple example or something. I don't know if we can find a simple. I'm going to think about something. Let me just write this down. We need to somehow make this. I need to because I cannot talk exactly about what I'm doing at work. So we need to make a more general example. Or let me put this into here. where is this? Yeah. But I can't talk about my experience. I mean, I can talk about how does stuff work. I just can't tell you exactly how I'm doing stuff at work. Okay, I can show you code or something, but I mean the general stuff does still make sense. So and maybe let me mark this for next. A time series data example. Does not necessarily need to be Kafka. Because Kafka, we're coming to Kafka. We're going to look at Kafka and yeah. I mean, this with Kafka, it's not that hard. I mean, if you I think also I think let me just quickly check something. I think Cloudera also has an example about this. Let me just Cloudera Spark example. Or no, not Spark. Spark Kafka example. Using Spark streaming with Apache Kafka. No, that's not it. If I'm not finding it within a minute, then I'm going to show this to you next time. This was in the blog somewhere. Blog is not real. I can't find it right now. Yeah, that's Nick says. Nick says I bought a drone and want to gather data from its sensors. So let me just bring this quickly in here. So the idea would be drone sends data to, for instance, IoT Hub in Azure, then to Kafka, then to Spark, and boom, you can work with it. Yeah, this is basically the essence of this. It's always tricky that your drone is online and can send data, but it's mattering basically what you're doing with the data and how you're processing it. But I mean, with Kafka, okay, let's do it this way. Let's not get into too much stuff. So what we are going to do next time we're going to quickly go over the Kafka basics. We are doing we're looking into how to read and write with Kafka from Spark, or read write Kafka with Spark. And we're going to look at time series data. A simple example. I think this absolutely makes sense, and it's not that hard. And I have the Kafka already set up here, so let's kick this stuff and let's focus next time on this. Let's put this into the backlog. So we're going to move stuff around. Oops, this chat is not up to date. Next time we get Nick to fly his drone. Yeah, Tim Span is Tim is the man. Tim's very good, especially he's working a lot with Ni-Fi. So Tim's awesome. Let me just check. So this we have, this we have, this we have. Reading data frames. I mean, it's not that complicated. You have you can read Parquet files. We already did this last time. You can read CSV files directly into it. I'm guessing text files as well. So this is not that hard. Modifying basically everything you can do with SQL. You can very easy go here and say select year title from input. Can you? I think you can, but how can you only take few numbers from one column? Let's just SQL take take a number or take chars from column. Get specific. Take number of chars. Maybe one of you already knows this. If I want to, for instance, in the year column, if I want to take only the year basically has 4 digits. I want to use the second two. How was that? Because stuff like this you need a lot to basically select substring. Yeah, I don't want to write to the cloud, and I don't want to set up stuff, and I want this stuff to be as accessible to other users or to someone who tests this out as possible. I don't want to, if somebody watches this stream and want to replicate what we're doing, I don't want him to first set up some stuff in the cloud and then work with it. That's stupid. Oh man, how is that? How's that working? How can I take the first 4 digits or the second 2 digits? Take number of characters in a string. Oh, man. I don't want count. I don't want length. Count. Because what maybe guys, maybe one of you already knows this and is a super nerd in in SQL. I'm having this year column and I want to cut this. I only want 90, 91, 83. With map, it would be super easy. I would split this into the words, and then I say take 5 or take 3 or take this, and then I can basically say start at this, leave 2 out, and then take 2. It's super simple, but here, how am I doing this in SQL? Take number of take. Select only n numbers of varchar. Substring. Okay. Let's just try this here. Select year. Select substring. Select substring. Year. 2, I'm guessing. The star is going to go away. Yeah. So that's easy. And here is the cool thing, that this is what I like here with Zeppelin and so on. Now I just tried it here. Then now I'm going to leave this out again. I'm going to do this, and now I'm taking this and I'm copying it here. Boop. That, and I'm going to take title again. Boom, boom. Execute it. I'm sure I have an error in it. Or not. Awesome. Then I'm going to go down and just execute this again, and boom. That's it. Okay, so it's basically modification of this stuff is super simple. And yeah, that's it. And yeah, we already seen writing a parquet file is super easy. My mouse is already empty. Super. The other stuff was, how was that? Store Spark data frame into CSV file, into local CSV file. So I'm searching always off screen because I don't know what what this thing is showing me. How to say, Stack Overflow is awesome. Okay. Okay, you need to do some transformations. You can convert data frame into an RDD. This will create a file path, and then you store the RDD. Okay. Okay. Interesting. Okay. So this stuff is easy. Today is a quicker stream. Yeah, Stack Overflow is it's awesome. But as always with these sites and with these tools and with these tutorials, when you're coding, you're getting to a point where this stuff doesn't help you, where you need to figure out stuff for yourself. This is always the same. This stuff helps you. The examples are always super easy, super simple, just and then when you're using it in production, there are some minor tweaks here and there that you need to do that people are not showing you. That is more or less the IP of the companies, and you need to figure this out with trial and error. Which configuration is the best? Where are the tricks? And the problem is with these tricks, you always learn this while you're running this stuff, and yeah, this is annoying. But for the simple examples, this is okay. Bombax says, just wondering what's the most significant difference between map functions and data frames. Using both methods, you can quite easily process the data. However, using data frames, you can use pure SQL. Yeah, SQL that's basically the idea behind all this stuff is with a you can see this here. A RDD is more or less, it's a resilient distributed data set. And if you're coming from the Java world, you know this here is an array. And in this array, you have how do you say this? You have variables in it. And so in this array, this is a RDD with an array of string and integers. So it's there are pairs in them, or there's a pair in one side is a string and one is an integer, and you basically have rows, big rows with strings and integers, string integer, string integer, and with a data frame, this is all getting drilled down into a table that you're used to with SQL, and so you can use it with SQL. It's super. What is Zeppelin? Zeppelin is a tool, is a notebook tool, just like Jupyter, and this is you can run this on a server, and you can run this on your Hadoop cluster or whatever, and this can execute Spark jobs in the background. And the cool thing with Zeppelin is that usually what you need to do is when you deploy Spark stuff, I have been coding with Spark, for instance, with a Java Scala IDE. Then you code with a Scala IDE, and you use Maven for managing the dependencies, and then you code everything down, and then you, for instance, create a fat jar, and so you're going to put all the classes or all the dependencies in the fat jar, and then you deploy this one to Spark, and this runs on Spark. And so you need to compile this, and then you go onto the cluster and you deploy it on the cluster, and then you need a way of managing the deployment and so on. And with Zeppelin, you have your notebook, you can create in the notebook, and then you can run more or less directly here, and you can have a visualization, which you cannot have in a normal Spark environment. You don't have a visualization. So this is what I really like with Zeppelin. You have your notebook, you write your code, and then you can make SQL queries, and you can visualize the stuff, and you can visualize it as a table, you can visualize it as bar charts, as pie charts. Okay, this absolutely makes no sense. Area, line graphs, and scatter plots. So this stuff is amazing. You can also download the plots as CSV files and so on. So this is what I like about Zeppelin, and why I recommend it. You guys, I think it was Nick or someone on Monday on the stream said, yeah, Zeppelin is great until it breaks down. It was really funny. Dragonfly says you can implement machine learning models via the IDE too. I actually have no idea about machine learning. This is not my day job, and I'm not 100% interested in machine learning right now. I'm more the engineering, the data processing, the architecture. I'm also working a lot in the business nowadays. Nowadays, I'm working a lot in the business side of the whole IoT and data science field. And yeah, I'm missing coding. I mentioned in one of the last streams I mentioned serious coding. I haven't done serious coding in, I don't know, I guess now it's 1.5 years or something, and I'm absolutely missing it. I want to get back to it, and I want to use these streams to get back to it, because once you're in a lead position, and you don't need a lot of people, and it depends on when you're in bigger companies, there is getting an overhead, and the business is coming, or you need to be more involved in business. So you have your guys who are you're doing the awesome work and the fun work of coding, and you're the other stuff is also fun, but I'm missing coding. I have way too less time for coding nowadays. Muhammad says data frame versus data set is just that you can perform RDD transformations and actions like RDDs on it is more than that. Or is it more than that? So you can, okay, that's interesting. Yeah, I'm an engineer at heart. Absolutely. I have done so many years coding and learning all this stuff, and yeah, you're growing, but you somehow you need to keep your roots. You can. So here's the thing, you in the past years or 10 years ago, also in the past years, you have seen in the leadership positions, you have seen these not so technical guys. It's more like business people. Business people replaced the engineers in the leadership level, and it was more like management and not like leadership. Or it was more like management. The actual technical knowledge was always was more down at the operations level, and leadership was more only for leading the people. And you need to have master of how was that, art or some stuff. So, and I see a change. I see the change that leadership positions also need more technical knowledge. They need to have the vision where to go, and they need to more understand where all this, what is needed from them, and to get more down to earth and more hands-on. And I'm seeing this, and I've heard this from a lot of people, and so you need to know your roots, and you need to know the stuff. Of course, I cannot go into everything and become a master of only Spark. I know this is not possible, and you guys know this as well. If you're growing, at some point you need to let some stuff go, and you need to let other people do this. And so it's a journey, but I really am convinced you need this stuff. You need to, anyway, as an engineer or when you're getting team lead and so on, you need to know what's happening, what's up. You need to learn this, and you need to know this, and you need to apply this, and you need to know how to talk to people about this stuff. And this is always this is very important, and it's fun. It's just fun. This stuff is fun. You sit down, like we did here. You sit down. You think about code. What could I do? And then you struggle with naming variables, and then you're trying stuff out, and then you're going here and writing SQL statements, and then you display it, and okay, bar, and then here, okay, I've learned that 1991 there are in this data set 129 instances, and so on. That's awesome. Okay, enough ranting here. Data frames are basically similar to tables in relational databases. Yeah, Dragonfly is absolutely right here, as this is what I have learned as well. Okay. I don't want to keep you as long, such as structured data files, Tips and Hive, external database. Yeah. Lazy evaluation also for data frames. But yeah, guys, awesome stream. I hope this was helping you a bit. And next time I'm going to prepare. Next time, I guess that's already tomorrow. So I need to work on my preparation. And we're trying a example with some IoT stuff. Yeah. Okay. Thanks, guys. That was awesome. Again, if you want to support, please check out the Patreon, become a patron, and support the stream, support what you like, and check out the links for Amazon. This also helps a lot, and it basically costs you nothing. If you buy something anyway, just use one of my links. And yeah, man, you guys want me to stay here. The chat is going. Don't forget to share the code. Did we do that much coding? I think I can. I can just add this to the other code, or I'm going to find out how we do this. Yeah, data frame. This is what I have see when you Google and what we have seen JSON and Parquet and so on. This stuff naturally or how do you say this here? This is supported to go already into data frames. So that's awesome, and this is a very big help. Don't forget to share the code. I already addressed this. Also can read from distributed file systems, local file system storage, S3 and external relational database system through JDBC. Yeah, this stuff is amazing. It's amazing. Okay, Spark SQL's external data source API. I haven't seen this. I haven't tried this. Interesting. Data frames can be extended to support any third-party data formats or sources through the Spark SQL API. That's interesting. Afro CSV, Elasticsearch, Cassandra. That's cool. That's awesome. By the way, we hit 6,000 subscribers today on the stream. 6,000. Beginning of the year, we had 500 or something. Awesome. Okay. Thanks, guys. I don't want to keep you any longer. Thank you for the super support here and for the contribution in the chat. I think this is super helpful. Not only for me, it's helpful for you guys, that you can talk, that you can build a community and use these streams not only to hear me ramble, but to have a conversation amongst yourself and help solving some problems and talking about some stuff. And I think, for instance, this stuff, the last stuff Dragonfly wrote, this is very, very helpful. 5,000 of them are my village people. Your village people. I know what you mean. The village people. It's bigger than it's about twice the size of the village I'm living in. So, village of data plumbers. Yeah. Okay, guys. Let's wrap this up. Thanks for the support and thanks for being here. And let's meet again tomorrow. I'm going to create another stream for tomorrow, and then tomorrow 10:30 p.m. German time. I always write Germany time. Somehow Germany time that sounds cool. It's Germany time, baby. Okay. Bye bye, guys. See you tomorrow.